to introduce this, I'll tell you, I'm a retired submariner, and at the wardroom table, there were three things that we were not supposed to talk about. And one was religion, one was women, and one was politics. And I honestly thought that there should be a fourth, which was motor oil, because it seems to me that an awful lot of discussion about motor oil is based more on faith than it is on fact. When I saw Lake give a presentation similar to this 7 years ago to our Porsche Club section, it was a revelation to me. It was the first time I'd ever seen anybody give a really good technically based presentation on oil. And I knew I wanted to bring this to the Mercedes Club at the right time. And I was finally able to track down Lake and get him to do this. So I really appreciate him spending the time with us this morning.
I can introduce myself. Gary was on the right track. So, so as Gary was saying, oil is one of those topics that is very controversial. If you want to start a fight on any internet chat room or discussion board, just talk about motor oil and say something, anything, regardless of what it is, and you're going to get people arguing with you. It is very funny in that way. For those who don't know me, my name is Lake Speed Jr. My dad is Lake Speed, who is a retired NASCAR driver. He spent 20 years in NASCAR as both driver and team owner for most of his career. Probably in some ways, almost more famously than NASCAR, my dad is also the only American to ever win the World Karting Championship. And you might think, karting, what's that? In Europe, karting is like AAA baseball for Formula One. My dad raced against Ayrton Senna, Alain Prost, Teo Fabi, Ricardo Patrese, Elio De Angelis, if you happen to know the Formula One guys from that era. And Dad actually beat Ayrton Senna in 1978. And he's the only American to ever go over there and win out of that group of guys. So karting's big time in Europe. It still is today. And Dad's actually does, me and him together actually both do vintage go-karting. So we're vintage karting guys. I like old stuff. Which is why I like having my old Mercedes as well. That is my hand-me-down for those who joined later. If I can share are you sharing my screen yet or no?
Yeah, you can.
Okay, you go ahead and do that. And we're going to share desktop 2. Perfect. So, that 1983 Mercedes 240D was my grandfather's. They then handed it down to my mother, and then she handed it down to me about 7 years ago. And that was my daily driver when I worked in Memphis, Tennessee. Now, I still live here in North Carolina, but I had my job with Driven Racing Oil. We had a facility over in Tennessee. It was a distribution facility, and then I kind of moved our office over there. So I was back and forth between here and there. So that was my daily driver in Memphis. And we kind of laughed that, part of Memphis we were in wasn't like the best part of town for manufacturing and that kind of stuff. So, but it was the only car that never gets stolen. And it was because it was a stick shift diesel. No thief could know how to drive that thing. So we always had fun with that. But anyway, my background coming out of racing is that I worked for Joe Gibbs Racing for almost 15 years. And in that role, we actually had our own engine oil. We actually made our own engine oils, gear oils, transmission fluids, power steering fluids, greases, things like that, because we were able to formulate and create a competitive advantage by doing so. And, a big part of that was NASCAR up until about 5 years ago still ran flat tappet camshafts. And when the motor oils began to change in the early 2000s, and the amount of ZDP, zinc dialkyd thiophosphate, the technical term, when that began to change, we began to experience camshaft failures. And of course, we didn't have any idea why. We just knew we were losing cams, and of course, we blamed the cam companies and things like that. And eventually found out that no, it wasn't the cams, it wasn't lifters, it was actually the motor oil. I remember when my dad had his team, we'd go to the Kmart in Port Orange, Florida, when we were down there for Daytona. And I would go buy, had the company card, go out there and buy every quart of Mobil 1 5W30 they had on the shelf, come back, pour it in the engine, and run the Daytona 500. No problems. Well, then somewhere in the early 2000s, you couldn't do that anymore. I mean, I literally remember probably 98, 99, somewhere there, going and buying oil. And then 2 years later, the engine builder saying, no, you can't do that anymore. That you can't happen. Okay, yeah, somebody had changed. And so Gibbs had responded by building their own oil, made to their own spec, and do all the testing. And for 15 years, I was in charge of that program. I did all the testing, all the formulating on the oils. So I'm also a member of a group called the Society of Tribologists and Lubrication Engineers. There isn't a tribology degree anywhere other than Auburn University now. They just started it a couple of years ago. So when I was going to school, there wasn't the ability to be a tribologist, but that's what the role that I have. And then a couple of years ago, I moved to Total Seal piston rings, which you think, what does piston rings have to do with that? Well, 40% of friction in an engine is the piston ring rubbing against the cylinder wall. So as a tribologist, the area of most opportunity actually is the piston ring and cylinder wall interface. So that's really where my interest of going to Total Seal, which Total Seal was a technical supplier for Joe Gibbs Racing. So we actually had been using their products for over a decade and had developed certain things with them and did a lot of working and testing with Total Seal. So it really wasn't a big jump moving to Total Seal from Driven and being part of Gibbs. Total Seal supplies, Formula One teams and IndyCar teams, NASCAR people. We also do stuff for the U.S. military, for all kinds of different things. If this got a piston, we can make a ring for it. So it's fun. We get to do some fun things. So when Gary reached out and said, hey, we just talk about oil and things like that for the Mercedes Club, I said, yeah, sure. Actually, again, I have one. I drive it on occasion still. It was my daily driver for a long time. I'd be happy to share what I know and answer questions. And the idea is I really do. I want your questions. So start thinking about the things that you've always wanted to know about oil and get answers on, and we'll address that. But before we jump into that, I want to kind of lay some groundwork. The way I kind of look at this is the few slides I kind of prepared this morning is like orienting your map. Now, you can have a map. I know people don't use maps anymore because, we've got these phones and everything anymore. And so it just tells you where to go turn by turn, and it orients the map by itself. But in the old days, you had to know which way was north. So you figure out how your map is, orient your map correctly, then you can figure out where to go. Well, navigating this world of oil, which you've already said is loaded with misconceptions and myths and pitfalls and ideas and opinions and not a lot of data, really need to orient that map so we can give you some framework, some guidelines, and some data to work from so that all this can make sense. So that's what we're going to do first. Now, we'll do that. I got a little analogy for you I'm going to show you, but we'll go ahead and jump into the slides first. And as Gary said, we're calling this the theology of motor oil. And the first thing is, what does oil actually do? So the key thing is oil isn't just a lubricant. Oil cleans. It's what prevents rust. It's what carries away combustion debris. Especially think about an engine, be it a gasoline or a diesel engine. What kills that oil is contamination. If you think about it, no one changes their gear oil or transmission fluid every 6 months or 3,000 miles, even in the old days. Well, why? Well, engines have blow-by. It's the blow-by that contaminates the oil that makes it go bad. The same base oil that's used to make engine oil is also used to make transmission fluid, gear oil, turbine oils. Now, there are some turbine systems, like big power plants and power gen stuff. They may change the oil every 20 years. Let that sink in for a second. It's still hot in a turbine. The difference between a turbine and an engine is turbines aren't exposed to combustion byproducts. Engines are. All that combustion gas, heat, carbon, soot, unburnt fuel that gets past those piston rings that we make, that total seal, gets into your oil. That contamination is what kills the oil. And one of the jobs of the motor oil is to actually carry away that contamination, try to get it to the filter so you can begin to remove some of that to try to keep the engine running longer and keep the oil from living longer. So it's not only is it trying to prevent rust and things like that, it's carrying away that debris, carrying it to the filter. So cleaning is really important. Cooling is also a huge factor. In an air-cooled engine, engine oil is actually doing more than 40% of the cooling. But even in a water-cooled engine, there's different studies that will kind of put the number somewhere between 30% and 40% of the engine cooling is actually done by the oil. Valve springs by themselves, just the compressing back and forth of valve springs generates heat. There's a device called a spintron that actually can spin just the valve train. So the pistons aren't moving. There's no crankshaft, especially a straight rod through it. And the whole valve train moves. And it's a way we can dynamically test the valve train in a race engine to be able to fine tune so we can run higher and higher RPMs for greater and greater efficiencies. That device, when there's no combustion going on, the oil temperature will still reach 200, 220 degrees oil temperature without combustion. Let that sink in for a second. Where is that heat coming from? It's coming from the valve springs. So there's no water passages to cool valve springs. What cools your valve springs? It's the motor oil. The oil splashing up from the crankcase on the bottom side of the piston is actually pulling more heat from that piston than goes through the piston rings. It's fact. In fact, with the NASCAR engines and some of the Formula One engines, they'll run upwards of 4 piston oilers, 4 jets of oil spraying up on the underside of the piston to cool the piston. And in doing so, it allows them to run even thinner, smaller piston rings. So you still maintain the seal without having to have all the extra weight and friction of a large piston ring to transfer the heat. So those are just some of the ways to kind of think about, what does oil do? People kind of fixate on oil as a lubricant and forget that it cleans, it cools. Hey, and modern engines that have variable valve timing, things like that, they use the oil as hydraulic fluid. No different than a jack. What moves it? It's fluid, right? It's fluid power is what you see in any kind of press, any kind of jack where you're using hydraulic force. Well, in today's engines that have, I said, variable valve timing and things like that, you're using the oil as that hydraulic fluid. And then also oil as a seal between that piston ring and the cylinder wall and the ring and the piston. Oil is the gasket. If you put it together completely dry, you could put a leak down tester on and check the amount of the blow by, the leak in the cylinder, and you'll see it's really high. You put a drop or 3 of oil in there, and you'll find out all of a sudden that the blow by drops dramatically. The compression goes way up. Well, why? Oil is acting as that gasket to fill the voids between the two. So oil is a sealant. It's also what lip seals on a crankshaft. That seal actually should not touch the journal. It should be a very fine, thin film of oil. The gasket between the seal and the crankshaft. That's especially that surface tension is what it's using. So those are some things to think about oil beyond just being a lubricant. Now, obviously, it is a lubricant. So let's go ahead and get into how oil acts as a lubricant and what does proper lubrication look like. So proper lubrication can be defined as the 4 R's. You want to have the right oil, right? What does that mean? Right oil means it's the right viscosity and additive type for the application. There's engine oils and there's gear oils. Gear oils really shouldn't be in an engine because they're not designed to handle combustion. And motor oils shouldn't be in transmissions or rear ends because they're not designed for the extreme pressures and the sliding forces in those applications. So it's about having the right chemistry for the application. That's really, really important. So you want the right viscosity and the right chemistry for the application. That's the right oil. But then you've got to get it to where it's supposed to be, when it's supposed to be, and enough of it. In fact, most lubrication-related failures are actually not the oil. It's one of the latter three. So when there's ever a problem with an engine or any kind of piece of equipment that's lubricated, and there's a failure, you should ask yourself those 4 questions. Okay, did I have the right oil, right additives, right viscosity for the application? Did it get where it's supposed to be on time and enough of it? And a lot of times you'll find that it's one of those 4, and then that can help you focus in. So understanding those 4 R's is really, really key in order to extend the life of your equipment and get the maximum life out of it, the maximum durability, the maximum performance out of it. Is really fine-tuning on these 4 questions and asking those hard questions and figuring it out. We do all kinds of crazy things for cylinder bore finish because that's one way to make sure that your engine is actually sealing up properly and you can maintain the life of the bore, maintain the life of the piston rings. Well, how do you have proper lubrication of a piston ring? Well, those 4 R's, right oil, we already talked about that. What's the right place, right time, right amount? Well, it's the surface finish. So you sometimes get to use tools like this called a profilometer, which can actually measure surface finish. But you can't measure surface finish with your eye. You can't measure your fingernail. You have to use a device like this to actually measure surface finish so that you can actually understand, do I have enough oil retention on the cylinder wall to properly lubricate and to seal the piston ring against the cylinder wall so the cylinder wall doesn't wear out too quickly. Things to keep in mind. So again, that's proper lubrication. And then there are different stages of lubrication. So once you even get all those 4 R's right, there's still different things going on all the time in the engine. So the 3 stages of lubrication are called full film. That's like your water skier skiing on the water. And the water skiing is probably a pretty good analogy. If you've ever been water skiing, or at least you kind of understand what happens in water skiing, when the boat is not moving, the skier's in the water. We call that boundary lubrication. There is no oil film. At that point, you're completely dependent upon the additives in the oil to prevent metal on metal seizure, welding, galling. But then as the boat begins to move, the skier will begin to come up out of the water. It's not fully out of the water yet, but it's not also just dead in the water. We call that mixed film. Then once the boat's up to speed, the skier pops up and is riding on top of the water. So that's called that full film hydrodynamic wedge is the engineering term we call it. The thing about that is the skier on top of the water is full film, where you're completely riding. The parts are separated by a film of oil. As the boat slows down, say going to a no wake zone, skier begins to sink back down. That's the mixed film. Again, when the boat stopped, the skier's in the water, there's no oil film anymore. That's boundary condition. So what does this have to do with engines? Well, let's think about your camshaft for a second. The camshaft in the engine is kind of the brain of the combustion cycle, if you will, when air is going in and when air is going out of the engine, because that's all our engine is a big air pump. So when the cam lobe is lifting the valve, it's opening against pressure. That spring pressure is what's loading the camshaft in lifter contact. That's metal on metal contact. That's what we call that boundary condition, which is why almost anybody that has an older car has probably heard the word zinc or ZDDP. This is why, because it's the ZDDP, the zinc, that provides the anti-wear film, the sacrificial protection that protects during that boundary condition. Because the valve train is going to live in that boundary condition. So that cam's opening and closing, opening and closing, opening and closing. The higher the RPM, the faster it's happening. It's the ZDP, the boundary film, that's providing that protection to prevent pure metal on metal contact, which is going to lead to scuffing, scoring, galling, and failure of the part. That mixed film is where, it's kind of a transition point. Really almost the whole engine lives in that mixed film at engine startup, which is why startup is so critical. Having, enough oil flow and things like that at startup. But then your engine bearings, they're going to live in that full film condition. When that crankshaft's rotating, the connecting rods are spinning around, that's full film. That's what protects those. So when you see bearing wear in your engine, you got to make sure you've got enough viscosity to prevent that. If it's valve train wear, then it's going to be related to the additive package. And your poor piston rings, you know what? They have to live through all three of them every single cycle. That's one reason why I love piston rings, is that because every single engine cycle, that piston ring goes from boundary to mix to full film, back to mix, back to boundary. Why is that, you might ask? It's because every single engine cycle, that piston goes from dead stop at bottom dead center, accelerates to its maximum speed at mid stroke, and then by top dead center, has to hit the brakes and slow back down again. And on a compression stroke, especially in a diesel, you have two things working against you. You have decreasing speed and increasing cylinder pressure. So if you've been looking at the chart up there, you can see the math is that they call it the Strybeck curve. The math is viscosity times speed divided by load. Well, piston headed toward top dead center, you've got decreasing speed and increasing load. The math works out that you're going from full film into boundary in no time flat. So that's where things get really interesting. So again, understanding what components in the engine operate in which lubrication regimes kind of helps you figure out, well, what is that right chemistry? What is that right viscosity for my application? So this is kind of that framework we've been talking about, how you orient the map to make sense of all of these things. And then one last thing before we really kind of get into the Q&A part is, how does ZDP actually work? Because we've talked about zinc a little bit, and I'm sure this is something that's not new to the whole group in terms of the topic of zinc, but the actual chemistry of zinc is it's a polar molecule. So it's got a positive charge on one end and a negative charge on the other end. So it will be attracted to any ferrous surface. Well, most older engines, camshaft, things like that, are based out of some kind of iron or steel material that contains iron. So it's a ferrous material, so it's attracted to it. Under heat and load, the ZDP molecule decomposes and creates a film. So there has to be heat, there has to be load for the ZDP molecule to actually decompose and create the film. That film that covers the part is kind of like having snow on a mountain range. So if you think about the part being rough, because no smooth piece of metal is actually smooth. Again, that's why we have surface roughness testers to actually quantify how rough is that surface. So if you think about, say, the Rocky Mountains in the summer when there's no snow, how jagged they look. Well, then in the wintertime, when they put snow over them, the snow smooths it out. It fills in some of those valleys and rounds off the peaks. Think about the ZDP film just like that. So it's smoothing things out. And then because it's sacrificial, when those parts are rubbing together, what's actually wearing isn't the metal, it's the ZDP film that's wearing. That's how it prevents. So it's wearing off and replenishing, wearing off and replenishing. That's the function that's going on inside your engine all the time. So with that being said, before the last thing I want to kind of show and talk about before we get into the Q&A part of this is, so I am going to go back and stop sharing my screen. Can I share just myself? Can we do that? Diane?
If you just stop sharing, you'll be there. Yep, you're there.
I did it.
You got it. All right, good job. Thank you. All right, so let's talk for a difference, just real quick, about where people get confused about oil. So this is a set of mid-Mateo dial calipers. Now I can roll back here and I can grab, say, this flat tappet lifter right here. So this is a DLC coated flat tappet lifter that came out of a NASCAR Cup engine. If I want to know the size of this part, if I want to verify that this should be an 842 lifter diameter, I can grab my caliper, I can slide up, and it's at 874, right? So I can tell, okay, this is the size of that lifter. If I want to know the length of it, I can measure it just like this. All right, inch 880. It's really easy when you have a physical part and a pretty simple measuring device to quantify what it is. I don't have to trust the manufacturer of this part to know that it is what they said what it's supposed to be, because I can measure it. Unless I have an oil analysis lab in my basement, I have to trust the manufacturer that this is the viscosity they said it is. It contains the additives they said it does. About a couple of years ago, I went into one of my long-term customers that we had done oil development with for years and years and years. And you go visit them normally, you might be there 30 minutes or so, talking about whatever you need to talk about, and then move on to the next person in town or whatever. I was there all day, like 4 or 5 hours. And we were measuring parts and doing things. He's like, let's go eat lunch. And we're sitting down to eat lunch. He said, you know what, Blake, what the difference is between oil and piston rings? I'm like, no, Paul, tell me. He said, when it comes to oil, I just have to trust you. I can't quantify that what's in the bottle is what you say it is. All I know is I put it in the engine, and as long as the engine doesn't blow up right in front of me, I just kind of have to believe and trust that it's doing what it's supposed to do. Whereas at least if I have a part, we can measure the part. We can measure the piston rings. We can look at the piston rings. We can look at the wear in the piston rings. It can tell us a lot without having to trust. And that's where things really get weird, right? Is that with motor oil, we're doing so much trusting that it's hard to really know. And unless you're doing something like used oil analysis, you really have no data. You're just trusting. And that's what opens up that opportunity for so much speculation and myth and all of this. And, you know, the one last thing I want to bring up as an analogy to kind of, again, providing framework in all this is all I'm trying to do is just kind of give everybody framework of how to think about oil and lubrication in general. Think about tires. There is no best tire. The very best tire for road racing in dry conditions is the absolute worst tire for driving on the street in the rain. I think that's kind of, very logical. Everybody can understand that. If you've ever driven on slicks in the wet, that's not a good thing. Okay, well, there isn't a best. And that's the whole thing. As long as you kind of approach it and understand there isn't a best. Application always dictates chemistry. There is no superior base oil. Sorry, all the different group 4 or 5, all these advocates and stuff. Cummins Engine Company up in Indiana, probably the best engine builder on the planet. They don't use the highest grade cast irons and materials to make camshafts. And it's not because they're insufficient and they're trying to save money. It's because they realize that it's not about the material quality necessarily. I mean, there is a minimum material quality. Don't get me wrong. They're not using the cheapest junk available. But as opposed to just having a higher tensile strength material for the camshaft, they also recognized that the surface finish of the camshaft is actually more important. That if I have a very rough finish on my camshaft, then I'm putting all the load, all these little peaks. It's kind of like doing push-ups on your fingertips. You're never going to do as many push-ups on your fingertips as you will your palms. And the point that I'm trying to make with this is that everything's a combination. You can have the best individual components, right? Quote unquote, best, and put them together. There could be zero synergy. Think about people and teams and stuff like that. It's pretty rare that you put together a lot of superstars and it works. Why? Because there's no chemistry within the group. And then there's other teams that do extremely well. They kind of go beyond what you would say is the sum of the parts. It's synergy. That's the key to engines. That's the key to motor oil and to formulating is synergy. So those are kind of my caution words about just looking at things. And a lot of discussions never focus on those things. They talk about what the base oil is, what the additive package is. They're looking at things in segments, not as the whole. And that ignores those synergies. And that's where a lot of this stuff gets lost. And that's why there is so much confusion. And that's why it shouldn't be a topic of conversation at the dinner table. And you certainly shouldn't talk about it on the internet. So hopefully that's giving everybody some perspective, and hopefully that's lots of fuel for thought for questions. So with that, I'm ready for any questions anybody's got for me.
Okay. I apologize for dropping out just before I did the introduction of guest speaker, by the way. So you did a wonderful introduction of yourself. I wanted to.
I had to do it a couple of times.
Yeah, you have. Before I get to the questions that are coming in about what all they should use for their engines, I wanted to ask you why modern oils may not have as much ZDDP as one might need.
Okay, that's easy enough. Actually, I have a slide for that. So if you want to, here, let me do my screen sharing thing. Where did I go here?
Yeah, you should be able to still do that. You're still a co-host.
Yep. So let's go back over here, and we're going to hit share, and we're going to play from current slide, and then I'm going to go over here. Okay, so the main reason oils have changed is because engines today have things like catalytic converters on them. They have things called DPS, which are diesel particulate filters. Even the newer gasoline direct injection engines are also being equipped with particulate filters. So those devices can become clogged by the ash that comes from some of these additives. So where in the old days, the additive levels were higher, there was more ZDP, there was more detergent type additives in the oil. Well, now the ZDP has been reduced because primarily the ZDP, that same film that would form in your camshaft, would also form inside the catalyst. So now it's basically covering catalyst area, which reduces the efficiency of the catalyst. So whereas maybe early 90s, catalysts could live maybe 80,000 miles. Well, the EPA wanted those catalysts to live over 100,000 miles. Well, the only way to do it was to reduce the amount of ZDP or build bigger catalysts. Well, because catalysts contain precious metals like platinum and palladium, it's really expensive. The OEMs didn't like that idea. They were much happier to reduce the amount of ZDP in the oil. And the fact that they were coming around with, roller cam valve trains, which are, live a lot longer. They're much more reliable. There's less issues with oil consumption, or I say oil consumption, but oil longevity with a roller cam. So you were going from flat tappets towards rollers. And so it was very easy to reduce that ZDP in production engines and be able to achieve that increase in emissions equipment life. And especially, like I said, when you come in with particular filters and things like that on the diesels, and now the gasoline direct injection engines, those reductions in that smaller and smaller box for the off-the-shelf oils that's what's driven those changes, are those government regulations based on emissions.
Great, thank you. And I think that's one of the questions that someone had put in chat as well. I'm going to shift over to the chat questions from From Neil Dion, he says he has two mid-80s Mercedes-Benz V8s, 500 SEC and a 560 SL, and a 1960s Land Rover. He says he's been told that the best oil to use in all three is a good diesel oil, Rotella, etc. What is your opinion? Thanks.
Okay, great question. So there was a time in the past, not too distant past actually, where a diesel oil was a good idea for older engines. And the reason for that is that up until what's called API CK, which if you look at the screen down there, if you put this slide back up real quick, I can do it because I don't have a bottle here that will me do this real quick. Okay, so that little donut right down here, if you're familiar with API oils and stuff, there's these little donuts. If you look at that little rating, so that the S series are for gasoline engines, the C series are for diesel engines. All the stuff prior to CK still had to pass a gasoline flat tappet engine test. The name of that test was called Sequence 3G. It had been around for a long, long time. So you had these diesel oils that didn't have the lower levels of ZDP requirement that the gasoline engines do. So all the S stuff since the early 2000s all has lower ZDP. So for an older engine, you do not want to put anything that has a donut on there in it. Just don't do it. You're just Russian roulette with your engine if you're doing that. Now, the diesel stuff prior to CK had more ZDP, passed a flat tappet test, and as long as you had essentially a stock engine, stock valve train, you hadn't done anything performance modifications to it, yeah, worked great. No problems at all. Problem is API CK rolled around and they eliminated the flat tappet engine test. So now they don't have to pass that test. And the newer diesel oils are, because the particulate filters and things you're putting on the diesels, they have lower levels of ZDP. In fact, like the new Delo LE and all that kind of stuff, lower levels of ZDP. So there are still some higher ZDP diesel oils available in like some applications. But really, the better choice would be a classic car oil. There are several manufacturers that make specific classic car oils that have a higher level of ZDP, that have seal conditioners and things in them, that have storage protection additives. Because a lot of classic cars, aren't daily drivers. They do sit in storage for a while. And with the modern fuels that contain ethanols and things like that, that can cause more corrosion in the engine, which we can talk about that later if we want to get into fuel stuff. We can a little bit. That it's better to use a classic car oil formulation than it is a diesel oil formulation.
Okay. From Luis Garcia, taking everything into account, what is the best oil for 80s turbo diesels? Can you use synthetics?
Okay, so here's the thing with synthetics. The seals in your engines that were built 60s, 70s, 80s, 90s, they were made for a mineral-based oil. And what I mean by that is that during that time period, the refining process that was the dominant process was called solvent extraction. And I won't get into the details of that unless someone just really wants to geek out with me later on, then we can talk about it. But essentially, they mixed solvent into the base oil to strip out impurities. Well, once they do that process, there's always some remaining solvent left in the base oil. I mean, not a high percentage, but those trace amounts of solvent left in the base oil made the seals swell. So the seal manufacturers counted on that. So they knew that they would, if you put in these oils, because of that remaining solvency, would cause the seals to swell, therefore work and seal properly. That was part of the equation. And where the whole synthetic oils that make your engine leak came from is that synthetic oils, guess what? They're not solvent refined. They don't have that level of solvency. It will make the seals shrink. Now, all your modern engine stuff built from the 2000s forward were all designed that seal materials changed, and they were designed knowing that there's these synthetic oils in the market that are better for fuel economy and all these other things that aren't going to make the seal swell. So we got to take care of it by itself. So they changed the material composition of seals to accommodate for that. With that being said, you can run synthetic oils in older engines as long as the oil has seal swell additives in it that were designed for an older car. Back to previous question, it's better to run a classic car oil. So I'm going to go ahead and tell y'all right now, I'm not going to tell you a brand. I don't work for any one company, and I'm not going to sit there and advocate and tell you you should use, Driven, or you should use Lucas, or you should use Mobile. I'm not going to pick a brand. What I'm going to tell you is what types of chemistry you should look for, and then let you choose which brand you trust. Because in the end, the right way to pick an oil is this. Do not start with a brand. The brand's the last choice, not the first choice. So what you do is you look at the application. What is the application? Is it a modern daily driver? Okay, then I'm going to be looking for an oil that meets the viscosity and technical requirements of that engine. If the engine's still under warranty, then you want to buy an oil that meets the manufacturer's spec so that you don't do anything that would put you outside the vehicle warranty. All right, so that you begin right there. If the owner's manual says it needs to be an API SP oil, needs to be 0W20, okay, then you find a brand of oil that's 0W20, that's API SP, and you choose the brand you trust to make sure that what's in the bottle every time. Back to Paul Kessler, his conversation. Who do I trust to be consistent? That it's going to be the same thing every time. That's where that trust factor in choosing the brand, and it may be the choice that the brand choice is, okay, I can buy this at a store close to me. The price point seems reasonable to me. So it's not just all about trust. It all comes back to availability and price, all the things that we do every day in making every purchase decision that we make. But the key point from the technical aspect is application is going to dictate what kind of chemistry, and that's going to be the viscosity and the additive package for the application. Say it's a 1983 Mercedes 240D. Okay, I'm going to need to run an oil that's at least a 15W40. In fact, really for an engine that's that old, it's got a lot of wear, I probably really want something closer to a 2050. So I need a heavier viscosity oil in that application. Also, because that's an old flat tapped engine, I'm going to want something that has that higher level of ZDP. So I'm going to be looking for a classic car formulation that does, because it is a diesel, that still meets some of those diesel credentials, in which those things exist. In fact, most of the classic car oils on the market are an older diesel engine package. So they started off with. It's just the ones that you can't buy anymore are just available under those brands now, is the reality. So again, application is going to dictate that chemistry choice. And then it's about, okay, well, what do I have access to? What's the price point? And let those other market factors make your decision for yourself.
So I'll go to Alice's question. I know she has to leave in about 10 minutes. It's going to be one you're not exactly going to answer. It says, what does my 560 SEC need? She has a 91 560 SEC, and she asks, what brand has the zinc needed? Thanks.
Okay, so the best thing to do is, hey, you got your owner's manual. So go to your owner's manual, look at what the viscosity recommendation is. See what spec it called for. Being a 91, you're going to go with basically a classic car. Let's just say it's a 1030. You look it up and say 1030 may be their application. then what I would say is there are lots of good brands. All right, I'm gonna list off a couple companies here that I know make classic car engine oils. Motul does, Driven does, Lucas does. So you've got brands that make classic car oil. What you want to do is go look up what viscosity specification is right for your engine, and then go find one of those brands that has that classic car formulation and use that. Now, I will say this. My personal opinion for those older vehicles, if you've not been using synthetic, don't try to start it now. You can do a semi-synthetic if they offer it. That's just fine. Most semi-synthetics are usually somewhere in the neighborhood about 90% mineral oil, 80% mineral oil, and a little bit of synthetic. It's not going to hurt anything to run a semi-synthetic in a car that's been running conventional oil. I'm not a big fan of going from giving an engine that's only run mineral oil for 30 years, giving it synthetic. And the reason why is it's going to shock the seals. The seals are going to get pissed off that you change the chemistry. Best analogy I can give you is in NASCAR, we went from running unleaded fuel, or sorry, running from leaded race fuel to unleaded fuel. And when we did, every fuel cell we had in the shop just started to crack and do all kinds of weird things. We replaced them with the exact same brand fuel cell, and there was no problem. What happened? Well, we had been using those fuel cells for a long time. They had acclimated themselves to the leaded fuel. And then when we changed to unleaded fuel, it got mad. No different than the old biblical story about old wine and old wineskins, new wine, new wineskins. It's the same thing. This is nothing new. Once something becomes accustomed to something chemically, when you change it, it tends to react poorly. So for the sake of your vehicles, if you've only been running mineral oil, stay on mineral oil or maybe semi-synthetic. Don't go to synthetic if you don't have to.
Okay, great. Here's an interesting question. I have 10 SLs from a 1956 Gullwing to an SL65. I've used.
Wow, that's cool.
Yeah, that's pretty neat. I've used 0W40 Mobil 1 for years. Mobil 1's approved by Mercedes-Benz for newer cars. Comments on all for a 56 Gullwing and a 1960 190 SL. Most of these cars are very lightly used. 0W40, 15W50, something else? Thank you.
Okay, well, to really get detailed on those applications, the thing I need to know are what are the bearing clearances? Because that's really going to dictate what viscosity oil to run in the engine. Essentially, the wider the bearing clearance, the thicker the oil needs to be. Now, part of the trade-off is, like you said, they're not, normally driven. They don't see a lot of use. So startup flow, you can go too thick. I mean, one of my favorite analogies when talking about all that kind of stuff is oil and chemistry is Goldilocks and the Three Bears. Not too hot, not too cold, just right. It is balance. So you want an oil that's not too thin, but it's also not too thick. If it's too thin, it won't be thick enough to keep the parts separated with a wider bearing clearance. It needs thicker oil. But if the oil's too thick, it can't flow and get there. Back to right oil, right place, right time, right amount. So if the engines are still stock, they've never been rebuilt. Again, back to the owner's manual. What does it say? All right, let's go with the viscosity that's closest to what was listed in the owner's manual. That's the best route to go. If the engines have been rebuilt, okay, let's go back and talk to the engine builder and let's find out what bearing clearances they used. Then we can begin to spec from there. And I worked for Driven for a long time. So I just happen to, I'm referencing this because I know what resources they have. On their website, they've got a digital version of their catalog. in that catalog, there is a chart that shows recommended viscosities based on bearing clearance. So you can know, okay, if I found out from my build sheet from my engine builder what my bearing clearances are, you can go look at that chart and say, okay, this is what viscosity to run based on those bearing clearances. And I'm really confident in that chart because I'm the one that designed it.
That's great. Okay, next question from Sam. He says he has a 62 W111 Mercedes 220 SB fintail and a 63 W110 Mercedes 190C fintail. For my oil changes, I always make the following cocktail: Lubrication 20W50, MOS2 anti-friction, Lucas oil stabilizer, and zinc additive. I want to know if the above is a good idea to use, and I'm concerned that using a 20W50 oil plus a Lucas oil stabilizer, which is like that honey-like substance, may be too thick of a mix, especially on startup. Do you have any thoughts?
I've done all I can to resist doing this when he said that. And again, I'm not picking on you. Great question. Thank you for asking the question, actually, because that is pretty common that people get their own little cocktails. My first response to that is when you start combining different additives together, be it MOS2, be it stabilizer, whatever it is, you are playing chemical Russian roulette with your engine. It's just that simple. In your case, say taking Lubrication 2050, blending in the Lubrication oil additive, okay, the chances of those two not being compatible, pretty low, right? I mean, if there's anyone that's going to do testing between an oil and an additive, is a company that sells both the oil and the additive. So there's not a lot of risk with doing that. Now, if you're using a different brand additive, let's say it was a XYZ brand additive with the Lubrication oil, that's back to full-on chemical Russian roulette with your engine. Definitely not recommended to do that. If you think that the oil you're using is deficient, that it needs more zinc, something like that, get a different oil. Don't try to fix it. It's just way better. And so to the second part of the question, is it too thick, things like that? Okay, for everybody that's listening that has one of these vehicles, if you really want to know whether or not what you're doing is working, you need data. Not just that it starts up, it runs, it doesn't smoke, it doesn't make noises, and it still runs, then therefore everything must be good. You need to do oil analysis. Without oil analysis, you have no data. None. So oil analysis is the most important thing to do. No different than going to the doctor and having a checkup and then them drawing your blood and doing a blood check to see how you're doing. If you do this at least once a year with your classic car, then it's doing your checkup and you know what's going on. Obviously, I highly recommend the Speed Diagnostics program. Some company that I helped my daughter get started, and she does it. And so, yeah, I'm a homer on that one, the full disclosure. But we also did it because we recognized that after years of doing oil work, that these same questions always come up, and you need to have a way of checking. And you need to be able to know, okay, well, what are we looking at? What's it doing? And, most big labs are designed to work on diesels and industrial applications. What I mean by diesels, I mean diesels that run 10,000 miles, 15,000 miles between oil change intervals. So that what's good for them or what's bad for them is really different in terms of what's good or bad for your application. So, I mean, I'm not saying you can't get data from those labs that you can use. They certainly can. And typically their data will be cheaper to acquire. the question is, well, what do you do with that data? And that's where the speed diagnostics deal provides interpretation of that data within the context of high performance vehicles or classic cars. Because in reality, it's more damaging to go out there and crank up your engine every weekend and let it run for 5 minutes and shut it off throughout winter storage than it would be to go track your car for a whole weekend. Mm-hmm. Just think about it. I mean, people think, oh, racing, you're really wearing it out. I've seen more awful wear results from engines that had maybe 20 miles on them because the owner was concerned about, the springs taking a seat or whatever is going on. And they go out there and they crank their engine, once a month or something like that during storage. Just let it run for a minute and shut it off. Or places where they were, had a bajillion cars and they were driving the cars around every day, playing chess or whatever, Jenga with the cars, because you get fuel dilution. And fuel dilution is really what kills your oil more than anything else. It's the contamination of the oil that really is what kills the oil. And the only way to check that is oil analysis. So I'd highly recommend, if you're really serious about, maximizing the lubrication and then maximizing the longevity of your engines, oil analysis is your first thing you should invest in before choosing a different brand or different type of oil. Because if you really can't change something for better that you can't measure. You have to be able to measure first to be able to make progress on anything.
Yeah, I will comment that I do oil analysis on every one of my cars every time I touch the oil system, basically. And I've been doing that basically since I heard Lake talk 7 years ago, and before he started his company. I think you pretty much already answered this question, but I'll ask it just to make sure Kim understands the answer. Kim Stasis says, for an older 67 Mercedes-Benz 3-liter gas engine, would synthetic be okay? It's been on conventional oil all its life. Thanks. I really do think you've already answered that. But
yeah, stay with conventional. If you've already been going down that route, again, your risk reward ratio, something my dad taught me growing up, is pounded in my head. Risk versus reward. There's really not a lot of reward to go to a synthetic in an older engine. Just not worth it, in my opinion.
Got it. Okay. Kim Dias asks, I've got a 1968 250 SE, and I was always told the 20W50, but I'm convinced that I'm not using what is best for the vehicle. Would love to know a good recommendation and if anything should be added to it. Thank you for your time.
I'll say, so an older engine like that, 2050 isn't necessarily the wrong choice by any means. There's two things I would check based on that. Number one, I would go look at your owner's manual. If the owner's manual still exists, I would go look up and see what the manufacturer, what they called for. If 2050 is within what they spec for that engine, keep using it. There's no problem with doing that, especially if it is of the correct type for the older engine. Just because you go to AutoZone or O'Reilly's or something and they have 2050 in there does not mean it's going to have the level of ZDP. If it's got that API donut on there, and I can think of a couple of brands right now that are at every AutoZone across the country, and they've got 2050 and it's mineral oil. Then you flip it over, there's an API donut on it. It's 800 parts per million zinc oil. It's just what it is. And so all the older engines like that, it's better to be running a classic car formula. And then so that's the chemistry part. Now the viscosity part, I would say your first reference would be go look at the owner's manual and see what it is. If you don't have an owner's manual and you can't find out, what you really want to do is you want to look at your oil pressure at idle. When the engine's hot idle, you need to be able to make sure it's got sufficient oil pressure. Once it has sufficient oil pressure, you're good. If it's got, 1.5, 2 bar oil pressure at idle, you're good. You don't need to be any thicker than that. Because more than likely, if you go thicker than that, you're going to probably be giving up startup wear. And because these engines don't see a lot of extended runtime, they're going to see more cold start. You don't want to be too thick.
Okay, great. And I think you've already answered this one, but if you want to elaborate, it's from Deborah Beck Sweet. Why did oil companies change the formula in the early 2000s?
EPA, simple as that. The EPA went to the car manufacturers and said, car manufacturers, your new vehicles have to meet emission standards for a longer period of time. That used to be they had to meet them for up to 80,000 miles. Now they have to be up to 120,000 miles. And they didn't do it all at once. It was phased in over about a 10-year period, that transition from 80,000 miles up to 120,000 miles on the catalytic converter performance. And that was with OBD2, right? We went from OBD1 to OBD2. So now we've got OBD2 is onboard diagnostics. That's where your cars began to have a port where you plug in and you could read the computer. So when you went to OBD2, now we're able to read the performance, emissions performance before and after the catalyst. So now we can measure it. Back to measuring something before you can really change something. We're able to measure the performance of the catalyst over time. Now we want to extend that performance, and the OEMs and the car companies decided as a group, as opposed to building bigger catalysts, but more platinum, more palladium, that would raise the price of new cars accordingly. We would keep the same size catalyst, work with the oil companies to reduce the level of ZDP in the oils in order to achieve that extended catalytic converter performance life.
Okay, great. Okay, this is from Lloyd. He says he owns an 85 300D turbo diesel with very low mileage, 117,000. He says he puts on way less than 3,000 miles per year. Is changing the oil and filter annually adequate?
Yes. Yeah, if you're putting on less than a couple thousand miles or 3,000 miles a year, then an annual oil change is just fine. Really, depending upon what kind of oil you're running, if you're only putting on 1,000 miles a year, you could probably go 2 years. A lot of it depends on how you drive the car. If the miles you put on are all short trip driving, then you have to change it at least every year. If the miles you put on, or I drive at least 30 to 40 miles every time I turn the ignition, you could probably go further than that. You might be able to go a couple of years.
Great, thank you. This is from Alan Orth. How important are oil specs such as NOAC, flash point, pour point, etc.?
You can get way lost in the minutia on those things. For example, NOAC. So NOAC's a big one that all the oil companies and people talk about for marketing and stuff. What people don't tell you about NOAC is that as a manufacturer, I can run that test 30 times, and there's going to be bounce based on atmospheric conditions, what actual sample from the top of the bottle, the bottom of the bottle, all those things. I get to report the best result, not an average, the best. So it's very easy with oils to get caught up in what I call spec sheet racing, where everyone's pounding their chest. Oh, I got Group 4. I got this. I got that. I really don't care what that spec sheet says. You know what I care about? I care about what my used oil ounce report tells me. Because I've actually seen a non-synthetic oil that on a spec sheet would be probably no one's favorite oil, whip every other oil with all the fancy stuff on oil analysis and on actual measured engine wear. Because the synergy of that package, that what that blend was with what the base stock was, what the additive package, how it all worked together in a specific engine, it whipped everything, hands down. It was a quarter of the money of some of the products tested. So you can't just look at price tag. You can't just look at spec sheet. In fact, You can look at a spec sheet just to make sure it's in the ballpark for correct additives for the application. That's what you use it for. But I would not compare brand to brand to brand to brand just on spec sheet alone.
What a great answer. I thank you for that. And, you mentioned oil analysis a few times. And what y'all don't know is I actually took a course from Lake on oil analysis. And one of the things that I'm kind of thinking about trying to do maybe is ask you to talk to us about oil analysis in a follow-on text session. If you'd be
Sure, happy to. Yeah, to me, oil analysis is the micrometer. Mm-hmm. All right, this is the dial, slide gauge, but me, it's like, okay, I know that I'm interested in this part. Okay, I can sit there and talk about this part, theorizing this part all day long. Until I have a tool to measure that part, I really am just speculating. So it's great to have a conversation and talk about these things in general terms so we can orient our map when it comes to oil. But the only way, the tool for this is that.
Okay, let's proceed on. Amy McKenna asks, does time of year and seasonal temperature changes affect the type of oil used? For example, 20W50 be too thick in the winter? Thank you, she says.
It really depends upon where you live. So if you live in Minnesota, yes, that's a very relevant question. If you live in Miami, Florida, no, not at all. Especially if you live in San Diego, right, you use the same stuff year round. Don't worry about it. It really depends upon the environment you live in. Essentially, put it this way, the bigger the spread in ambient temperature throughout the year in your area, probably the wider the split in viscosity grade you're going to need in your oil. When you live in a pretty narrow range where it doesn't really change that much, you're not going to need to worry. And the thing is, I'd say there's no reason anymore to have different viscosity choices for winter and summer. The multi-grade oils already take care of that for you, which is why you'll see, say, like, Mercedes, Porsche, BMW, you see them going towards 040s, 560s, things like that. Well, it's, again, European car manufacturers where they have basically colder climates than we do here for the most part on average. In the US, they need those lower numbers before the W, because the W doesn't stand for weight. It stands for winter. So the lower winter grade means it can be colder outside and you can still safely start your engine. That's all it means. It doesn't mean anything else. No matter what anyone's ever told you or you've ever read on the internet, the number before the W is basically a measurement of winter starting performance. The lower the number, the colder it can be outside and you can safely start your engine. Don't think about it any other way. Never try to relate the number before the W to the number after the W. It's two completely different tests, two completely different measurements that do not correlate with each other. It just doesn't happen. They don't correlate. So don't try to correlate them. The colder, if the number after the W is your high temperature flow rate, that's what you need for your bearings. So whatever viscosity grade your OEM says in the manual after it, be it a 50 or a 40 or a 30, okay, that's the summer high temperature grade. If I live in Miami, I can run 10W30 all year long. I don't have any problems. If I live in Minneapolis, Minnesota, I probably want a 0W30 because it's going to get cold enough that I'm going to need that better winter cold cracking performance. So I'm going to need to go to a 0W to begin with, but my engine still calls for a 30 when it's warmed up. So I need a 0W30 versus a 10W30. I hope that helps.
Yeah, I see she's clapping. Okay, great. From Lowell Newfield, my dealer is continuing to encourage me to allow them to flush my engine with an additive in order to remove engine sludge and thus increase longevity. Is there any merit to this type engine treatment?
No, that's just snake oil.
Extra dealer profit center, right?
Yeah, put this way. There are cases when someone has an older engine that's come to them, say from a used car acquisition, and they don't have any idea what service was done, when the last time the oil was changed, and when you drain the oil out, chunks start coming out of the drain plug. Okay, in that application, you need to flush the engine out. Now, you don't need to have a flush oil to flush your engine out. You can just put oil in it and run it and flush it out. But in that case, you do need it. If you're doing normal maintenance, normal oil changes, there's zero reason to do that. That's just, I was going to call it carpet bagging, but it's it's just bad, right? You don't need to do that.
Okay, thank you. Alice says, shock is exactly what happened to me when I was talked into using. Horrible rattle and other problems. I assume going back is advised now. She was talking using synthetic oil, shift from conventional.
Okay, so in some cases, you can go back to conventional oil, and whatever issues cropped up when you went to synthetic will go away. It's not guaranteed. If for some reason the change in that shock led to some kind of permanent damage, then it's not going to replace itself. It's not going to heal itself. But I've seen applications, opportunities where switching up and going back to a conventional oil actually did resolve the problem. So I would give it a go as long as the engine's not, really getting worse, right? If the symptoms do not continue to get worse once you change to mineral oil, then just let it go, give it some time to come around. But if the symptoms get worse, then you need to call time out and rethink your strategy.
Okay, great. Well, here's one you're going to love from Jay Hickson to everyone. Please say again the name or contact information for the Oil Diagnostics Company your daughter runs.
Sure. It's called Speed Diagnostics. You can see it's only 1D, right? And all the contact information is right there. Don't use the phone number. She is a teenager, or not teenager, but she's young. They don't answer the phone. Email, website works the best.
Okay, let's see.
Thank you for asking that question, by the way. As a dad, I'm happy about that.
From Yuan Ongpan, I live in the Philippines with very tropical, humid weather. Is a 20W50 too thick for my pre-2000s Mercedes-Benzes? I've been using Kendall liquid titanium and Castrol for a long time. All good? Also, are you a believer of ceramic treatments along with regular oil changes? Results seem to be good to me.
Okay, so in a really hot environment, when you're near the equator, typically, because of that ambient heat and how hot it is constantly, the higher viscosity grades tend to be very popular in those areas. So I wouldn't say it's wrong. The key is back to what does your owner's manual call for? If you're running a 2050 in, let's say, a 2012 engine that calls for 040, you're using the wrong oil. Now, do you need a 040 in the tropics? No. You could probably be better off running a 10W40 or a 5W40. That would be better. You don't need that big, giant, wide split because you don't really have the winter conditions at all. But you don't want to have an oil that's too thick. As I mentioned earlier, I am not a fan of additives. I don't care what technology they say it is. I don't care. When you put something else into an oil, you are playing chemical Russian roulette. Now, whether or not you've had good results or not, okay. I mean, we've all heard these different stories where somebody says, hey, I used XYZ additive and I gained 5 horsepower. But there's going to be another guy that says, I used XYZ additive and I lost 5 main bearings. Which one's lying? Neither one of them are. The reality is, in case one, the XYZ additive mixed properly, enhanced the oil, and they were able to get a better result. That's great. In the other case, it was a negative reaction. It didn't mix well. And the thing is, if you're using this, one brand additive, well, more than likely that additive isn't going to change in years and years and years to come. But as we've already documented, the off-the-shelf motor oils change all the time. I mean, just a year ago, API went from SN to SP. So you can be using the same brand oil, same viscosity oil, but what's in the bottle is completely different than it was 2 years ago, a year and a half ago. But you still put the same additive in, and the old package, it worked great. The new package, it doesn't. It's back to risk versus reward. No one's going to stop you. You have all the freedom in the world to put in anything you want to in any oil you choose. But you need to weigh out the risk versus reward of what you're getting. And engines are expensive, and they're very inconvenient to have rebuilt. I can just tell you that. So to me, I'm not a fan of additives, and I don't like them for that reason.
Okay, great. Just a few more questions. From C. Daltner, what is the minimum zinc level in ppm do you recommend?
All right, so that's a great question. So there's more than one type of zinc. So different types of zinc have different abilities. So it's not about necessarily how much zinc is in the oil. I'm going to give you a direct answer here. It's really about what type of zinc is in the oil. So the reason why I say that is don't fall into the more is better trap. When I tell you that your oil needs to really be 1,200 parts per million ZDP, is where you kind of need to be. 1,200 to say 1,500, that's a good window to be in. That's it. That's the window. Somewhere between 12 and 15 is where you need to be. More is not better. Don't fall into that trap. Now, for break-in, if you're having an engine rebuilt, you need to have more than 1,500 during break-in. That's really important. It's like putting primer down before you put down paint. So you need more ZDP during that initial critical wear-in stage. Once you're past that 1,200 to 1,500 window works just fine.
Great, thank you. This is another one from our friend who has the span of SLs from 55 up to the SL 65. He says, since oil chemistry has changed over the last 60 years, is a lower viscosity better to minimize startup wear, especially for low use cars?
No. So back to the viscosity grade, we have to make sure when we're talking about viscosity, that we're being really clear about what that SAE grade means. And again, I'm going to grab this bottle because it's here in front of me. So the 20W, right? That's your cold crank. That's your startup flow. The 50, there you go. That's counterintuitive, right? The 50 is your high temperature flow. This number has to match your bearing clearances. Otherwise, you will have increased wear and potential catastrophic failure of the engine. So it's really important not to drop this number in your engine. If it's designed for a 50, it needs to be a 50. Now, lowering startup wear is about bringing that number down. So if the engine's only going to crank up in cooler environments and run for short durations, well, then you could maybe go to a 5W50, and that would give you what you're looking for. But in case the engine did run longer and it got fully the temperature, you want to make sure you still have that 50. I hope that answers the question, is that don't get into, well, okay, I've been using 2050, but I need startup wear protection, so now I'm going to go put in a 5W30. And no. You got to maintain that after the W number for your bearing protection and high temperature protection, but you can go lower on the front number to get improved protection for that. Now, the trick is you're not going to find a mineral-based 5W50. They're going to be synthetics. So that's kind of your issue. There's no unicorns and rainbows when it comes to this stuff. Now, all the marketers are going to tell you they have unicorns and rainbows, but they're lying. So that's fine.
Okay, this is another one from Kim Diaz. Have you ever had experience with products like BG-MOA?
Yeah, again, I think everybody's been listening. I'm not a big fan of additives. I don't care what brand it is. I don't care what it's from. When you take an oil that's already been blended, just for example, I formulated oils for a long time. It's kind of like making a cake. Yeah, you can have your flour, your sugar, you can have eggs, you can have milk, you can have vanilla, you can have your baking soda, salt, all those things. It's not just about having all those. You have to put them together in the correct order for it to work. So there is blend order when you make oil. When you take an additive and you add it to that oil, there's that possibility of components not working. I mean, one of the things that I would spend time doing with every new base oil, every new additive that came our way, the first thing we would do is take probably about 10 beakers of existing known base oils, known oil blends, and then we would add some of that additive to them and just put them on the shelf and wait a month to see what happens, to see if it begins to cloud up or if it will mix or it will separate. What's going to happen? That's the reason why I'm not a fan of additives, because you just don't know. And to me, it goes back to the risk versus reward. My engine is worth way more to me than the interest of a science project.
Makes sense to me. Okay, looks like we have one more question in the chat from Luis Garcia. My shop is currently using conventional Pennzoil 10W40 in diesel engines from the 70s and 80s. Is that hurting the engine? That oil is not rated for diesel engines. Thank you.
I would not. I would, for a diesel engine, it needs to have a diesel additive package in it. Because one of the things about a diesel engine, it contains what's called dispersants, because a diesel engine creates soot. In fact, that's the biggest thing that causes wear in a diesel engine is soot. Half the diesel engine wear tests are soot-related wear tests. Gasoline engines are not formulated with the same type of soot handling additives that diesel engines are. So to get maximum performance and durability out of a diesel engine, it needs to be a diesel engine formulation that will contain the correct additives for handling the soot.
Okay. Yeah, I think actually Mercedes is delivering some diesels with gas engine oil in them too, which.
This is really key. I'm glad you mentioned that. So the big difference between American or North American API specifications and the European ACEA certifications are that in Europe, their specifications are like a ACEA A series or B series oil is designed for both gasoline and diesel engines. They break it differently. Here in the US, we break gasoline and diesel. We separate them. In Europe, they don't do that. The gas engines and diesels are together, and what they do is they break it out based on emissions protection. So the older engines that have higher levels of soot and they need those additives, those are in those classifications. The modern engines with DPS that are emissions controlled, they're in a different classification. So they break it out differently. So when you see, they say, they're using an engine that can be a gasoline engine, you're going to find out that it's an AC, it's a European spec. It's not a North American spec. Now, there can be engine oils that have both. Right? The oil marketer has worked and achieved certifications for both gasoline and diesel, the same oil, then that's fine. If they have certifications for both, then you can do that. Because what they've basically done is they've taken the gasoline engine and they've enhanced it with extra additives in order to be able to pass the diesel specs as well.
Great. Thank you for answering that one. I was wondering about that. Jay Hickson just added one for us. Do you also have a similar talk on gasoline? I'd love to hear your opinions in that area.
Yes, I do. As somebody that's been involved in this industry for a long time, as a tribologist, like you said, it doesn't take very long to figure out that, okay, what kills motor oil is gasoline and fuel. So I'm a member of ASTM as well and certified in both gasoline and diesel, taking courses. I've been to refineries. I know how that stuff works. So yeah, fuel is a big part of it.
Sounds like a future tech session then. Okay, another one popped in from Laurentio. Is changing the engine oil early in the spring a good idea to flush out any condensation from the oil formed during winter driving?
All right, great question. So, based on your thing is, if the car is driven during the winter, the key is, driving it long enough to get it up to temperature. If the engine comes up to full temperature, you don't have to worry about that. It's going to evaporate all the moisture and the byproducts and stuff out, as long as it gets to temperature. If it's only short trip driving during the winter, then it's a good idea to go ahead and get that stuff out of there, because it can do damage if it's short trip driving. Well, I tell people that have classic cars that during winter storage, here's the best thing to do, is to change the oil in the fall when you put the car away for storage. Then just let it sit. Hook up the battery tender and let it sit. Don't go out there and crank it. Don't do any of that kind of stuff. Just let it sit. In the spring, when the car shows start rolling around and there's concours and there's things like that, go drive your car. Enjoy it. Have fun. You don't put more than 3,000 miles on the car during the year, just change it again in the fall. Don't worry about it. That's all I got to do. It's that simple.
And one more question popped in from Barry. Why is time between changes important? Obviously, oil changes.
Okay, because as soon as you crank the engine up and run it, you're going to put contamination in the oil. So now you have acids and things that are there that are going to begin to degrade the oil. So if you crank the engine up and let it run for 10 minutes just to circulate the oil through the engine and all that, and then you put it away, that you don't run it again, that clock can sit for a long time. There was some storage oils we did work on that were designed to sit for 8 years. They could just sit. It's not going to hurt it. As long as you don't run it, it's not hurting it. You just let it sit. Now, the more you drive it during that time, even if it's only short trip driving, which is, again, the worst, you're putting contaminants in. So now it's not mileage based that you need to be changing the oil. It's time based. So back to what I said, you could be only running 1,000 miles a year, but if you're doing it 10 miles at a time, then you're going to need to change oil every year. If you put 500 miles a year on the car and it's 200 miles at a time, you can probably go several years before you change the oil. But the only way to know that is to test it. Don't just do it blindly. There's no reason not to measure. You can do the measurement and then you can know. Because everybody's application is going to be different. We talk about general rules, but the way you hone in is you have to do measurement to be able to get there.
Well, I'm surprised that this question hasn't popped up earlier. It's from Laurentio. Any advice on oil change intervals?
Well, that's it. This is how you determine oil change interval, right? You can start off and the general rule of thumb is the more highway driving you do, the further you can go in oil change intervals. That's general advice, right? more short trip driving means more frequent oil change intervals. There was a lady that worked for General Motors who passed away a few years ago. She was a real icon in the tribology industry. Her nickname was Sister Sludge. Her name was actually Shirley Schwartz. And her famous saying was that she could make anyone's oil fail in less than 3,000 miles. All she had to do was give it to her grandmother, because her grandmother lived in Green Bay, Wisconsin, and she lived 1 mile from church and 1 mile from the grocery store. And every day she'd go to mass, and every day she'd go down to the market and pick up some food. All right. So she drove twice a day, 2 miles at a time. It didn't take very long in that environment to kill the oil because of that short trip driving and the engine's running richer. And that leads me to the next point. The more off you are on your tune-up, if your injectors are dirty and it's dumping fuel, now you're going to have to shorten up your oil change interval. Regardless of what the generic advice is, fuel is what kills the oil. If I look at 10 bad used oil analysis reports where the engine's failing, 1 out of those 10 won't have a fuel problem. 9 out of those 10 are going to have a fuel problem first. That's the way it works. Fuel is the number one thing that's going to kill your oil. So you need to be doing used oil analysis if you're going to try to fine tune and extend your oil change interval. Anything less is worse than trying to find water with a divining rod, which apparently really can work, but you're totally guessing otherwise.
Okay, I have a few more questions popped in. Well, one, I think you've actually answered this. What's your measure of difference between short trip versus long trip?
The engine needs to reach operating temperature. So different engines that have thermostats in them and what they're set to. I mean, you really want to be able to get it. Here's the best way to do it. If the water temperature of the engine doesn't reach 180 to 200 degrees and stay there for at least 10 minutes, you've not driven it far enough to consider that long trip driving. Because the thing is, again, different size engines, different thermostats and all that. Oil temperature trails water temperature initially. So water temperature can go up faster. Oil temperature is going to rise slower. So you need to maintain that fixed operating water temperature long enough for the oil temperature to catch up. Because until you reach 212 degrees, the water is still going to be there.
Mm-hmm. Yeah, one of my cars is an older, or is a newer 129 chassis, and it actually has an oil temperature gauge on the dash, which is one of the things I use to make sure that I've driven it long enough to get the oil warm.
Right.
Looks like we have one more question here. Should a car be routinely started, say every 6 months for an hour, or just let it sit? I think you answered.
Let it sit. Let it sit.
Yeah, because starting the engine is the most horrible thing you can do to an engine.
Yep. We were from my last little sayings here is that a couple of years ago we were at a tribology conference, and the keynote speaker was a very respected guy in the industry, and he started off and said, "Okay, if who here has a car that has start-stop technology? Raise your hand if you have start-stop technology." A lot of people raise their hand and said, "Okay, if you own the car, you're not leasing it, you own the car, keep your hands raised." Of course, over half the people dropped their hands and said, "All right, I highly recommend to you guys who are still holding your hands up, disable the start-stop technology on your car." Because essentially, stop-start technology is just a legal way for the OEM to defeat the EPA fuel economy testing. That's all it is. It's going to wear out the starter, and it's going to wear out your engine faster. If you disable it, both things will live longer. That simple.
That's an interesting thought. And it looks like we've one chat. I've got that feature disabled on my car. I hate it. It's disabled. Interesting. Okay, well, we've gotten through the chat questions, and you've gotten through the things I really wanted you to cover in this too. This is exactly what I wanted for this session. I really appreciate your doing that.
I'm happy to do it. I didn't have to use my whiteboard. That's amazing. So,
well, no, I just really appreciate that, because this is kind of the message that I wanted to bring to the MBCA members about oil. It's very, very important. I think we should probably do a follow-on session on oil analysis, because I know how important.
I'd be happy to.
Well,
it'd be great to do that.
I think that'd be a lot of fun. You know, I use a lab that's different from yours, just because I started before you started your lab. And
it's fine. It doesn't really matter who you use. I mean, obviously, I'm biased, but in the end, I would rather somebody do oil analysis than not do oil analysis. And as long as you, as you know, you're using the lab and you're doing repeated testing, so you can build that trend line. That's the key thing, is doing the trend analysis over time. One sample is one point of data. It doesn't tell you a whole lot. When you start laying over multiple points of data, now the picture becomes clearer and you can better understand what's going on.
Good. So I'll work with you to try to do an oil analysis session sometime in the future. And I've got a comment in there on gasoline too. Don't forget that. So, all right. Yep. So do you have any concluding remarks that you'd like to say as we leave?
No, I just thank you for everybody's time here on a Saturday morning. I know there's lots of things people can be doing otherwise, so I appreciate the opportunity to come to speak to everybody, and I'm glad we were able to hopefully answer everybody's questions and give them some direction and guidance so they can orient that map and make sense of all this chemical confusion out there.
Great. Well, thank you for bringing your wisdom to MBCA. I really appreciate it.